as well. All right, so let's get started. Coercion and truthiness. Coercion and truthiness is something that is going to be pretty embedded in JavaScript. And it's something that you want to make sure you're very aware of because people use this very, very often. It's definitely one of those things where it's not really possible to avoid, especially if you're reading and writing code in the wild. It's a pretty fundamental thing, and what makes it harder is what makes it a bit trickier than other things is because the coercion truthiness oftentimes has a bunch of shortcuts or shorthand ways to do it. When you first read it, it may seem like it's really complicated and oversimplified. But hopefully, as you get used to it, as you use it more and more, it will start making sense, and you'll get more comfortable with it. Okay, so before we dive into these two ideas, let's do a quick primer on data types in JavaScript. There are essentially two main buckets of data types in JavaScript. There's something called primitive types, and there's something called non-primitive or complex types. So most of the things that we've seen so far, like numbers, strings, and booleans, are called primitives. The other types of primitives include nulls, undefineds, and symbols. For this particular curriculum, we'll be focusing primarily on the first three: the number, the string, and the booleans. And essentially, what makes a primitive type special, or at least what sets it apart from a non-primitive type, is primitive data types. And you can write this out. The most important part of primitive data types is that they cannot be changed once they've been created. So we saw this a little bit last night with the problem where you had to go in and capitalize every other letter, I believe. And so when we say when we say that we're using a primitive, it basically means, hey, if I use a value in a primitive, I can never change that underlying value. Now, if I have something that's like let x equal 6, I can change what x is, right? I can say let x equals 7 and then say x equals 8, right? I can rearrange what value that variable is, but I can never change fundamentally what 8 is, or what 7 is, or what 6 is. Similarly, with a string and a boolean, with a boolean, you can think of it as a true is a true, right? If I say let x equals true, I can then redefine x to be false, but I can never redefine true to be false, right? So true, once we've created it, it will always be true. Similar with false, once we've created it, it will always be false. Strings is the one that's a little bit harder, I think, for us to wrap our minds around, especially because JavaScript does it a bit differently than some of the other languages. If I create a string of lowercase a, b, and c, essentially what that means is that we can never change the value of that string ever again, right? That string will always only have 3 characters, lowercase a, b, and c. Now, what I can do is if I want to capitalize the first letter, if I want to capitalize the A, then what I'm able to do is I am able to create a brand new string with a capital A and then a B and a C. But I am not able to change the original ABC string, just like how I can't change a 6 or a 7 or a false or a true. Okay, so that's all we mean when we say primitives, is essentially these are the data types in which once it's been created, it can no longer be changed. The contrast to that will be something that we'll talk more about in later, I think the week after, and we call those complex non-primitives or objects, and those include things like functions, arrays, and objects. Hopefully by now, even if we haven't covered it directly yet, you at least are somewhat comfortable with what an array is. If you think about an array, I can create an array with 2 things, and I can always add more things to the array, right? And so that, because I am able to edit, because I am able to modify and change something after I've created it, that's what sets it apart from a primitive data type, right? So if I create a string with 3 letters, I can never add another letter to that string. But if I create an array with 3 items in it, or three values inside of the array, I can always add more values to the array, or I can take away things from that array. And so when I say change in programming, you'll probably hear a term more often called mutation or mutate. And so when we say what's the main difference between primitives and complex data types, we'll say primitives are immutable, as in they cannot be changed, and then complex types are mutable, or they are able to be changed after they've been created. Make sense so far? Cool. So actually for all of today's lecture, we're going to be dealing only with the primitive data types. So the numbers, the strings, and the booleans. So basically things that are primitives, i.e. things that once we've created, we cannot change. Okay. So this brings to our first kind of bucket of topics for today, which is coercion. Coercion basically just means change. And when we say coercion, usually what we mean is we're changing a particular value from one data type to another data type. Okay, so the most kind of obvious way we do this is through something that's called explicit coercion. And as the name indicates, explicit coercion is very explicit, right? It's very clear what we're changing it to. So here on line 6, I have an example of I create a variable called num, and I set it equal to the number 10. Okay. If I use this type of operator, which once again, remember, is a reserved word in JavaScript, right? It comes pre-built into JavaScript fundamentally. If I log out what type of num is, it's going to show up after I run the code on the page. But afterwards, if I create a new variable called lowercase string equals, and I set it equal to this string uppercase, I'll come back to what that means, class, and I pass in num, and I console log out string, and I console log out type of string again. Notice what prints out on the top right hand corner of my screen. Okay, the first thing that prints out is number, and that makes sense because after I run line 6, in which I create a variable called num and it's equal to a number value, I then console log out type of number, and I get back number. Okay, so that's what the first line of console log is. On line 9 then, when I create a variable called string, I pass in num into this capitalized string function. So what is that string function? Remember how on day 1 when I talked about clean code and why you never want to capitalize the first letter of a variable name? It's because in JavaScript, when you do that, basically JavaScript sees that and thinks, oh, you're talking about not a variable called string, you're talking about a class called string. We won't focus too much on what classes are over the course of this curriculum, other than just letting you know that every one of the primitive data types we've seen so far, booleans, numbers, strings, arrays, functions, these are all classes in JavaScript. Basically what that means is these are all pre-built in functionalities, or maybe these are all pre-built in data types that exist in JavaScript. And so every one of these data types has certain attributes that we can use. So on line 9 there, what this is just saying is by passing in num, lowercase num, into the string class, or in this case we call it the string global object, all we're saying is saying, hey, here's a number. Can we try to make this into a string? Right? And so the output of that is going to be a string version of whatever number we gave it. And so notice how on line 10 now, when we console log out string, it's not the capital string that we use on line 9. It's the lowercase string, right? It's the variable that we've created. And what value does that string hold now? Well, the lowercase string was assigned the value of whatever the string class returned when we gave it num. And so when we console log out on line 10, we see the lowercase string variable now stores the value of not 10 anymore. And when we print out, it's hard to see, but actually what it's storing is the value of a string with 2 characters, 1 and 0. And we prove this on line 11 when we say, hey, what data type is string? Well, now it's no longer a number. The data type for it is a string. Okay, and so this is called explicit coercion. And because very, very clearly there on line 9, we're saying, hey, take this thing that was some other data type and let's feed it into the string class, so we know that whatever we get back will be of a string type. So when we say coercion, this is our way of changing something from a number to a string.
So does that mean that string and number are the only classes that you can use, or are there other things?
Every data type that we've seen so far in JavaScript has its own class. So Booleans has a class, which we'll see later on. Functions, arrays, every data type that you see has a class. And really, we'll talk a little bit more about kind of some of the benefits of having classes when we talk about arrays. But for now, just know that everything that we've seen so far, every data type has its own class.
Okay.
Yep. Cool. All right. So that's pretty much explicit coercion. We'll go through a few more examples, but that's pretty much it, right? The coercion means we're changing it from one data type to another, and the explicit just means, hey, we're very upfront and transparent about what we're changing something to. And we'll contrast that with another form of coercion later on. So here on line 6, you'll notice we have not the number 1,000. We have a string on line 6 with 4 characters, 1000. We can console log it out, that type of string. And then here we see the number class, right? We know it's a class because the number, the n in number, is capitalized. And so now on line 9, we create a variable called num, and we feed in the string variable into the number class. And so we know whatever we get back is going to be of a type number. And so when we print it out, that's what we see. And there on line 10, when we console log out number, we actually no longer see a string, we see the number 1,000. And when we do type all of that, it gives us back number. So this is, once again, same exact idea, except now we're changing a string into a number, but it's still explicit because on line 9 there, I am very clearly feeding a value into the number class. Cool. Okay, so the reason why we made a big deal about explicit coercion is because there's also something that happens in JavaScript that honestly probably happens more often than explicit coercion, which is called implicit coercion. Okay, so the coercion part of it does not change. It's still exactly what we talked about earlier. We're still changing a value from one data type to another data type, except now it's done implicitly, which means we don't actually explicitly tell you what we're changing something to. So how does that look? Let's take a look at the example here. On line 1, we have a variable called sum, and we set it equal to the number 10 plus 20. On line 3, we have this variable called concatenated string, and we set it equal to whatever the value of the string 10 plus the string 20 is. And then lastly, we have the third variable that we've created called not sure, where we're actually adding a number to a string. Okay. So if we print out what all 3 of these values are, you'll notice for sum on line 7, well, that's pretty clear, right? We're adding the number 10 to the number 20. That's just basic math, and we get back 30. On line 3, we added 2 strings together, and so what we got back is actually pretty clear, right? It's a string with 4 characters, 1020. We're adding 2 strings together, so we're literally just shoving them end to end, much like how if I was to add 2 strings of hello and then world, I get hello world. Right? So far, those 2 make perfect sense. For the third one, you'll notice how we added a number and a string together, and the output of it was actually another string, which is 1020. So how do we get here? This is where implicit coercion kind of comes into effect. And so JavaScript, either fortunately or unfortunately, depending on how you look at it, it tries its best to do what you want it to do. And in order to do that, it sometimes makes some assumptions. And one of the assumptions in JavaScript with regards to type coercion is when you're adding a number to a string, what JavaScript will do first will say is, hey, let me change both of these to a string first, and then I'll do the concat or the plus operation, right? And the reason why it does that is because it just does it to be safe, right? Almost anything can be made into a string. Obviously, only numerical values can be made into a number. And so in this case, on line 5, when it says, hey, let's set not sure equal to 10 plus the string 20, what it does first is it says, well, I'm trying to add 2 data types that aren't the same. So let me convert both of them to a string first. So let me convert that 10 to a string 10, and then let me do my concat or my plus operation. And so that's why not sure is 1020. Cool. All right, so let's keep building on this particular example. Let's take a look at line 7 and say, hey, what if we add this number, this string 10 plus the numbers 20, 30, 40, and 50? If I do that, you'll notice how, well, if I just think about myself from the point of a computer, right? If I'm evaluating this equation from left to right, I say, what's a string 10 plus 20? Well, that gives me the string 1020. Sorry, what's a string 10 plus the number 20? That gives me the string 1020 because I need to change both parts to a string first, right? So then it becomes, what happens when I add the string 1020 to the number 30? Well, same exact thing happens, right? I have to convert both sides to a string first, so the 30 becomes the string 30, and then I have a string of 102030, right? And I take that all the way to the end, and so my final answer is the string that you see up above. Okay?
What if you put parentheses around the last four numbers?
Yeah, I'll do you one better. What if I just reverse the operation process, right? What if rather than making the string the first thing, I now make it the last thing, right? So this is essentially putting parentheses around, let's say 10 plus 20 plus 30 plus 40, and then we're saying let's add it to the string 50. Well, once again, if we're now actually thinking from the perspective of the computer, right? As it evaluates this expression from left to right, the first thing that it encounters is, well, what's 10 plus 20? And at that point, the computer says, well, I don't really have any decisions to make, right? These two are both numbers. So let me just add them up. I have 30, right? Great, so I'll keep going. What's 30 plus 30? Well, once again, I have two numbers, just basic math. 30 plus 30 is 60. And then I add 40 to it. Okay, once again, basic math. What's 60 plus 40? 100. And then I add 100 to the string 50. And now JavaScript says, oh, wait, hold up. You're adding two different values of two different data types. Let me convert both of them to a string first, and then let me use the plus operator. And so when we do this, the output we get is 10050. Okay, so the thing to be aware of here when you use explicit coercion, right, is obviously when you use implicit coercion, right? The tricky thing here is to realize is, one is you kind of need to know what assumptions JavaScript in this case is making on your behalf. So what happens when you actually try to add a number to a string? And then secondly, to Andy's question, the order of operations is very important. When you evaluate an expression, you need to think about it and approach that expression the way that the computer is going to, or the way that JavaScript is going to, right? And in this case, on line 7, because the computer evaluates it from left to right, it's going to do all the math with the numbers first. It's going to do a mathematical expression, and then another mathematical expression, and then another mathematical expression before it finally gets to the adding a number to a string issue. Okay. Everyone good so far? Thumbs up. Still makes kind of sense.
What if these numbers were like, if they had like decimal places, or if they were negative or something? Would that change the rules?
No. Yeah. JavaScript numbers are fairly flexible in that regard. Yep. Cool. All right. So implicit coercion. One of the things that you'll hear me say quite often is when you do a comparison in JavaScript. So basically, if I want to check if two things are equal, one thing that you'll hear me and Alex say a lot is, hey, always use the triple equal sign operator, right? So if I want to compare two things, I always do A equal B. Okay. You might also know that the double equal, right? The equals operators also exist in JavaScript. But why do we always very, very strongly recommend that you use the triple equals instead of the double equals? And the main reason for that does lie with kind of the both the flexibility but also the dangers of implicit coercion, right? So if I compare two numbers, 10 and 10, I get back true. Makes sense. However, on line 5, if you notice, if I compare the number 10 to the string 10, I also get back true. And if I kind of, like zoom out a little bit and think about it, I'm like, okay, that kind of also makes sense. But if I compare the string true to the Boolean value true, I get back false. And then obviously this kind of breaks down very, very quickly in that I see all of these edge scenarios that doesn't make sense. And so the reason why the double equal sign kind of has all of these maybe unexpected results is because when you use double equals, what JavaScript is going to do is when you're comparing two objects of the same type, right? So if you're comparing two numbers or two strings or two booleans, it's totally fine with that. But if you're comparing two things of different types, if you're comparing a number to a boolean or a string to a number, it will actually try converting both of those things to the same type first before it compares them. Now, the difficult thing is what it converts it to is not always very straightforward. Okay, so there are actually tables that you can look up online for how double equal signs does it, but just take it from me for now at least, is that like it doesn't always convert the values on either side of the equations to what you expect it to be. And so when you use double equal sign, that's kind of one of the biggest dangers of it, is that if you're comparing two different data types, unless you are very, very familiar and very comfortable with those rules, a double equal sign could give you a result that says true or false, when in reality that may not be the case, at least based on the more traditional human interpretations of it. So the reason why we always say, so the reason why we always say you should use triple equal signs is because double equal signs will try doing the conversion for you first and then comparing it. What triple equal signs does is it will say, hey, I'm not going to do any conversions for you. I'm just going to straight up compare the two values. And if these two values are of different data types, then they, by definition, can never be equal, right? So triple equal signs is more preferred in the vast majority of cases. It's because it's a lot more explicit. It's a lot more transparent and direct about what it's comparing. And so typically speaking, if I want to compare two different values and I know they're going to be of different data types, what I actually want to do is I actually want to use explicit coercion to convert one or both of the values to something else first, and then I use the triple equal sign. It's just a way to make sure that whenever you do these operations, you are being very, very clear to yourself and also to your readers how you're actually thinking about making the comparison. Okay, so that was a very long-winded way of just saying don't use double equal signs, because the way that it does the coercions for you on the back end is very opaque and potentially very dangerous. Always use triple equal signs. Okay, so just to wrap up on the coercion segment of this, the third type of coercion that we're going to talk about is Boolean coercion. Hopefully by now this will be a lot more straightforward, right? Coercion, once again, just means we're changing something from one thing to another thing. And Boolean coercion just means, hey, we're changing a value to a Boolean. Booleans, by definition, only have two possible data types, or two possible values, true and false. So, if you just guess blindly, you have a 50-50 shot of getting it right, I guess. But really what Boolean coercion is really valuable for is a Boolean coercion can take any value you give it and assign it either a value of true or false. Okay? There are a lot of, almost infinite values in JavaScript that can be converted. And the good way to think about it is even though there are millions, or there are an infinite number of potential values in JavaScript, everything can be bucketed into either values that become true when you convert it to a Boolean, or values that become false when you convert it to a Boolean. Okay, and the values that become true when you convert to a Boolean we call truthy values, and then the ones that are false become falsy values. Okay, and the good news for you in terms of knowing the differentiation is that in JavaScript there are only 6 possible values that are falsy. So basically there are only 6 possible values that when you feed it into a Boolean, when you convert to a Boolean, you get back false. Literally everything else, so infinity minus 6, is going to give you a truthy value. So for example, all these values, the string I am a string, the number 10, an array, an object, all of these, if I convert it to a Boolean, I get back true. However, what gives me false are these things only. So line 3 is an empty string. That is the only type of string that will be false. Every other string that's not empty is going to give you true. Okay, with a number, 0 is the only real number that will give you back false. every other numerical value is going to give you back a true. Null and undefined, those are their own types, so they're kind of unique in that regard, but nulls are falsy and undefineds are falsy. And then this very last thing, this uppercase NaN, that stands for not a number. So when would I get not a number? Well, if you remember earlier, when I try to do explicit coercion with a number, right? If I fed it the string 10, it's going to give me back 10, right? But if I fed it the string david and say, hey, can you convert that into a number for me? The number class is going to say, yeah, that's not going to work. I don't know what numerical value that would be. And so it's going to give me back an n, basically saying this is not a number, right? And so that's also a falsy value. And obviously the sixth one that we didn't put here, which can be assumed is if I convert quote unquote false into a Boolean, it's also going to give me back false as well. Okay, so zeros, empty strings, zeros, nulls, undefined, not a number, and false are the only falsy values in JavaScript. Everything else are truthy values, because for every other value, if I convert it to a Boolean, I would get back true. And the falsy values obviously gives you back false.
So there's probably an analog for all of these, but for to take like Boolean 0.
Yep.
Is that literally like Boolean and the character 0, or would it, if you did like Boolean 3 minus 3, for example?
Yeah. Yeah, great question. So when JavaScript evaluates code, it does follow an order of operations. If you put 3 minus 3 in between the parentheses, it will evaluate that expression first. Kind of like how basic math works, is like it will evaluate everything inside the innermost parentheses first, and then gradually work its way outwards. So in the example you gave, if I put Boolean and within the parentheses I put 3 minus 3, it will evaluate 3 minus 3 first. It will say that's a 0, and then it will say Boolean 0. Any other questions? Cool. Okay, great. So now we're going to start moving on to kind of the more practical applications of coercion. If you remember conditionals, Alec probably talked a bit about conditionals yesterday when we talked about the while loops. Not really the if statements, but hopefully by now you're pretty familiar with how those work. And obviously also the for loops. So a conditional expression basically is something that loops use to make a very simple decision, right? With every loop, really all the loop is really saying is it's making one singular decision, which is do I go or do I not go, right? Do I do one more iteration or do I stop, right? At every single instance, that's all the loop is in control of. And so if we think about that more abstractly, well, the loop is basically saying I have one of two possible choices, go or no go, yes or no. And that's mapped very, 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 very easily to a Boolean value, right? A Boolean value also only has two possible choices, true or false. And so because of that, a lot of times when we do loops, what's in between the parentheses is actually it's evaluated, but after it's evaluated, the computer actually is implicitly, so it's kind of not explicitly, it's transparently, or sorry, it's opaquely converting whatever that value is in those parentheses into a Boolean. And the reason why it does that is because it's basically forcing the assumption upon you, the writer, to say like, look, this if statement here, right? This if statement only needs to know one thing. Do I go into my code block, right? And so we're going to give it an expression within the parentheses, and that expression could return true or false. But if it returns, in this case, the number 5, well, the if loop doesn't know what to do with the number 5. But if the computer says, you know what, I'm going to take whatever is result you give me, and I convert to a Boolean first into true or false, then the if loop can then make the correct decision for the next step. Okay? So in this case, if I look at line 4 there, for that 5, if I convert that 5 into a Boolean, Well, every number outside of 0 or not a number that's being converted into a Boolean is going to give you back true. So basically that means on line 4, I basically have a true inside those parentheses. And so if true, well, if the if statement is true, then that means I go into the if block of code and I console log out in the if. And we see this actually very commonly, not just in if loops, but in for loops as well, which I'll talk about in a second, right? Here, another example. If I do if apples, well, JavaScript is going to say this if statement doesn't know what to do with your string apples. So I'm going to convert into a Boolean first, into a true or false, into a go or no go, and then the if statement will be able to execute correctly. And so when we convert apples to the string apples to a Boolean, I get back a true. So then if true, I go into the code block on line 4. Okay. And the first example is obviously if it's true, and the same the converse also applies on line 10 there. If I give you a false or a falsy value, aka a value that converts into a false if I try to coerce into a Boolean, then on line 10, the 0 says the 0 is going to be give me false, so I won't go into my if block of code. Instead, I will go into my else block of code. Okay. Oh, sorry. Does this make sense, everyone? Cool. Yeah. And so we didn't write the code out here, but if you think about the for loop in the middle, usually if I do like let I equal 0, or in the for loop, I'm trying to iterate through a string or an array, right? If I do let I equal 0 as my first statement, then I do I is less than array.length. Well, the I is less than array.length is basically doing the same thing, right? It's basically telling the for loop, do I go to the next iteration or do I not? Right? And so whatever you put in between that statement, that is also being converted into a Boolean. Now, what I do is I is less than array.length. That already gives me back a true or false value. So that tidbit is sometimes hidden from us. But I can just put back in this case, the number 10 in that statement, and it will return true every single time. And in that case, that'll be really bad because then it means my for loop will never stop running, right? But in almost all the loops and the if statements that you see, basically those are all being converted into a Boolean on the back end, because all JavaScript cares about for the purposes of this loops is, hey, am I going to get back a true value, a truthy value, which says I should go to the next iteration, or am I going to get back a falsy value, which says I should stop now? Okay. So because that's really important, this distinction between true or not true, another aspect of coercion is also this exclamation mark operator. In programming, we call it a bang, B-A-N-G, the bang operator. In other languages, you might also see it called the not operator. And basically, if I put a bang or an exclamation mark in front of any value, it's just going to give me the opposite Boolean value of that value. So if I have a true and I put a bang in front of it, that basically says, if I convert true to a Boolean, what do I get? I get back a true. And what's the opposite of that? False. If I have the string ABC and I convert that to a Boolean, what do I get? I get true. And what's the opposite of that? False. And so as I go through all these examples, all of these values are going to give me back false when I put a bang in front of it. That's why we call it the not operator. It kind of intuitively just gives you the opposite of whatever the current value, whatever the Boolean value of the current value is. Okay. So this also lends to its, I guess, something we can call it the double bang operator, or the two exclamation mark operator. If you try to think about this logically, it's going to actually get really, really confusing really quickly. So the way I always think about it is the double exclamation mark is basically another way to another way to implicitly convert whatever value you have into a Boolean, right? So this is almost equivalent to taking a value and passing it into the capital B Boolean global object or global class. Okay, so if I think about logically, what double bang does is, if I look at line 6, for example, the string ABC, is that truthy or falsy? Well, that's truthy. Great. So what's bang true? Well, it's false. Okay, and then what's bang false? It's true, right? So we essentially kind of come back to the same result. But I can also think of line 6 as saying, hey, what happens when I explicitly convert the string ABC into a Boolean class? I get back true, right? So both ways of thinking are going to take you to the same result. Up to you as to which one you want to pick. Okay, but just know that the double bang operator ends, or that's how it works. Thankfully, there's no triple bang operator. There's no bang bang bang, because if I do not, two of the nots inherently cancel out, right? So I'm still left with only one bang or one not operator, and so you only see single exclamation mark and double exclamation marks, but not anything more than that. And then the last thing we'll talk about are logical operators. Logical operators are things that also help us compare values, but they do so in almost a sequential kind of way. So the first one we'll talk about is AND operators. So the AND operator is made up of two consecutive ampersands. And so what AND does is AND compares two values. And if I think about making a grocery list, right? If I say go to the store and get me eggs and milk and bread, if you come back with just milk, well, the trip was kind of a failure, right? Because I needed all three things, right? If you come back with two of those three things, the trip is also a failure because, once again, I needed all three things. And so what AND does is AND will convert everything you have into a Boolean value, and it will check to see if every single one of those values is going to be true. Okay, so if I do 10 and 0, what it'll do is it will say, great, let's first check the 10. If I convert 10 to a Boolean, what do I get? Well, 10 is a number that's not 0, so I get back true. So at that point, the AND operator will say, great, my left side's cool. Let's go to my right-hand side. What happens when I convert my right-hand side into a Boolean? Well, when I convert 0 to a Boolean, I get back false. So then the AND operator fails, because it will say, hey, I needed A and B to be true, and at least one of these things was not true. Okay, and so if I extrapolate that out even further, if I do something like line 4 there, 10 and apples and zeros and no, what the AND operator is going to do is, once again, we're going to go back, put ourselves in the position of a computer. We're going to go from left to right, and we'll say, let's compare these things, right? Start one at a time. What's 10 and apples? Well, what's the Boolean value of 10? That's truthy, so that's true. So that's good. What's apples? Well, the Boolean value of apples is true, so that's truthy, so that's good. Great, what's the next value? The next value is and 0. So what's the Boolean value of 0? It's false. And at that point, this operator is going to say, great, I don't need to check the null, the fourth value, because I need every single thing in this chain to be true. And as soon as I find the first falsy value, I'm going to stop right there because I don't need to check anything else. Okay, and so contrast that with line 7. If I check the string lucky and the string number and the number 7, lucky converted to a Boolean is true, the string number converted to a Boolean is true, and the number 7 converted to a Boolean is true. So therefore, on line 5, when I console log out what gets returned, on line 5, I return back the first falsy value because I'm going from left to right. And then on line 7, I actually get back the last value, which is the truthy value, and that basically tells me, hey, every single chain up to and including the last value was a truthy value.
I have a quick question.
Yeah.
About the use of parentheses.
Mhm.
So like when I'm looking at what you have written here,
Yeah.
I probably would have put parentheses around like that entire thing in the return value 1 variable.
Sure.
And also when I have an expression like, let's say I'm doing if x is greater than 1 and x is less than 10, would I need to put parentheses around each one of those little expressions, or can it all just flow in?
When in doubt, I always put parentheses around things. They don't hurt. is my kind of like is my 2 cents on it. I think like whether I put parentheses around something is a very case by case basis, because there are times in which the order of operations matter, and the way a human reads it is gonna be different than the way a computer might read it. But I always put parentheses around things if I feel there's any ambiguity. both because it kind of really makes computer do things my way, and also because if I'm reading the code later on, I can very easily follow like the order in which the author is intending me to read this code. So I always put it around there. Yeah, I mean, this is there's no harm. And an example you gave earlier of like if a is less than B and C is less than D, in that case you might not have to, but I also personally would, just so that when someone reads the code, it's very clear. Like the and is referring to not A and B and C. It's like A and B and then C and D. So
Yeah, I think that's more so why I do it that way. It's just because I like the way it looks, but I wasn't sure if I was actually like messing something up by doing it that way.
yeah, no, totally. You're not messing something up. In fact, if you use parentheses, it's actually very like it's. I think it's actually a best practice. Yeah, I mean it never hurts, right? And also if you put in parentheses and it doesn't do what you want it to do, then it basically means there was a fundamental lack of understanding about how the code was going to execute to start with. Um, so yeah, okay, and then lastly, the others. Yeah, sorry, go ahead.
Can you one time again explain why the return value is 7? Like, shouldn't it be 2, like, versus 7?
Yeah, so return value. So if you read line 1 there, right? What the AND operator is going to do is it will, if it finds the first falsy value, it will give you back the first falsy value. But if it doesn't find any falsy value at all, it will give you back the last value. And when it gives you the last value and it's truthy, that just tells you, hey, like everything was truthy up until and including the last one too. Um, so I'm trying to think. Okay, yeah. So if you think of like a link of chains, if you can make sure that every chain has to go in sequence and the last chain is there, then it also must mean every chain before it was also there too. And so it's just like a nice way for you to really quickly at a glance say, oh, if I get a truthy value, it means it made it way all the way to the end of the sequence and everything was true. Yep. Yep. And then the other sibling corollary, whatever you want to call it, to the AND operator is the OR operator, and is made up of two vertical lines, which we call the pipe symbols in programming. If you look on your keyboard, it should be right under the delete key. But two vertical lines or two pipe symbols is the OR operator. So now this says, for my birthday, I want, a cell phone or a TV, or a computer, or food. Yeah. Like that just means if I have any of those things, I am very happy, right? So the OR operator works almost the flip of AND, where AND says I need to check every single thing to make sure they're all truthy. What the OR will do is it will say, let me check every single thing, and as soon as I find one truthy value, I'm done, right? I just need one of these things to be true. And so on line 4 there, if I have null, undefined, happy, and pumpkin, it will check null or undefined first. Is null, if I convert a boolean to truthy or falsely, is falsely. Okay, well, it's not going to stop, right? Saying I could easily find something else after that's truthy that would make everything true. So it checks the next thing, it checks undefined. If I convert undefined to a truthy value, I get back false. It's not deterred, it'll say let me keep checking. And then if it goes to happy, or rather the string happy, converts that to a boolean, and it gets back true. And at that point, it stops. It says, great, I needed at least one thing in this list of things to be true, and I found the first thing that happened to be true. I don't need to check pumpkin because no matter what pumpkin is, if it's falsy or truthy, it doesn't matter, right? Because for the purposes of an OR, I have at least one thing, right? For my birthday, I got at least one of the gifts that I wanted. I am happy. And so therefore, OR will always return the first truthy value it finds. Or if everything else in this sequence is false, so on line 7 there, everything is false, it will return back the last falsy value, right? So going back to the example with the chain link fence and Seema's earlier question, basically if I get back a falsy value from an OR operation, that basically just says, hey, the OR operation went through every single thing in this process, in this sequence, and everything returned falsy. And so when I see that falsy value, then I know that, hey, everything, including the last value, they were all falsy. And so it just gave me back the last falsy value. If I get back a truthy value from an OR operation, it actually tells me it found at least one truthy value. It doesn't tell me if there was any more truthy values after the first one, and it also doesn't really tell me where it finds it, right? But if I get back a falsy value, then I know, hey, it went to the very end and every single thing was a falsy value. And that is pretty much it, right? So today we talked about data types, so the distinction between primitives and non-primitives, aka whether or not you can change a value after you've created it. We talk about several types of coercion. We talk about explicit coercion, in which case you use a global class to change a data value from one type to another. And we also talk about implicit coercion, right? So basically, how do I what happens when I try and join multiple data types together? How does JavaScript think about that? And also, what are the kind of like the real world use cases in JavaScript in which JavaScript says, hey, this has to be a Boolean, right? Like in the case of an if statement or a loop. So it does that change or does that coercion for you. We briefly covered why you should always only use triple equal signs and never double equal signs. And then lastly, we talked about the bang and double bang operator, which gives you the opposite or the opposite of whatever value you're looking at, as well as the and or operator, which lets you check several things in sequence, right? And once again, remember the and the or operator, it basically converts everything to a Boolean first, and then just checks to see, are you true or are you false? Okay. Any questions on any of these concepts from today? Everyone's good?
I have a question.
Yeah.
I think I'm still unclear on like the double knot or the double bang.
Yep.
I think I'm trying to think of like an example where you would use that and like how it would make sense in like a real.
Yeah. If you ever want to convert everything to a Boolean, rather than typing out the word Boolean, you can just use 2 exclamation marks to do it.
Why would I want to do like what would I be doing where I would want to do that? Does that make sense?
So when would I ever want to convert anything to a Boolean?
Yeah.
Sure. Sure. So what if so let's say I have this string David, right? And I want to check to see I'm trying to think of like times in which like I've used double bangs at work. Like if I'm trying to do something that doesn't, so every example I'm thinking of uses the if statement. I'm trying to think if there is an example in which I don't use the if statement. Oh, so let's say I have an attendance list, right? And let's say I have a bunch of names here, and I want to know if anyone signed up. And my goal is to get back like if this is my list, like let's say there are 3 people. There's David, Rachel, and then let's say I'll put Seema here. And what I wanted to do is let's say people sign in and you sign in with their name. So on the sign-in sheet, I have David, and then I have Rachel, and then no one signs in for the third one. And essentially, I want to convert these into a Boolean. So when I say, hey, let's take a look at my attendance list, I want it to show true, true, and false. Right? The way I would do this is I could just go through every single item here. I could convert this to a Boolean, this to a Boolean, and then this to a Boolean. And this will give me back this true, true, false array that I want at the end of it.
Okay. That makes more sense.
Yep. And all I'm saying is this is literally the same exact thing as doing this.
Okay.
Right? It's just less typing actually.
Yeah, so I mean I would imagine that people use that shortcut a lot.
Yeah, people use bang a lot. The single bang, that's definitely more commonly used. The double bang, you're right, it's used less commonly, but there are use cases for it when you're not trying to evaluate something using an if or a for loop.
Thank you.
Yep. Cool. Okay, any other questions? Let me just go back to this table of contents here. All right. Well, if not, let me just open up my thing. Oh, I can't open. There we go. Oh, sorry. There's a question here. Oh, is truthy and falsy? Yeah, whether or not the E is there, I don't actually know for sure. Yeah, I don't think that they're real words either, so I think you can kind of get away with spelling it at your discretion. Cool. All right. So let me split you all up into the discussion groups, and then we will get started on the work.